Every day, millions of people do it. Some find it satisfying, others find it repulsive. But almost nobody knows what's actually happening inside the joint when you hear that pop. This is the sound of a bubble dying in your synovial fluid. To understand the pop, we need to go inside the metacarpophalangeal joint, what most of us simply call the knuckle. Your knuckle is a synovial joint. It's enclosed in a tough, fibrous capsule lined with a membrane that secretes synovial fluid. Think of this fluid as your body's natural motor oil. It lubricates the joint, reduces friction, and delivers nutrients to the cartilage surfaces. Synovial fluid isn't just liquid, it's a solution. Dissolved within it are gases, primarily nitrogen, along with oxygen and carbon dioxide. Under normal conditions, these gases are invisible, dissolved under the pressure inside your joint. When you pull or bend your finger to crack it, you're rapidly increasing the volume inside the joint capsule. According to the laws of physics, when volume increases, pressure drops. As pressure plummets, the dissolved gases, mostly nitrogen, come out of solution and form a bubble. This process is called cavitation. The bubble grows rapidly in the synovial fluid, reaching up to several millimeters in size. But here's where decades of scientific debate enter the story. For over 40 years, researchers believed the cracking sound came from the collapse of this bubble. Then in 2015, a real-time MRI study suggested the sound might come from the bubble's formation, not its collapse. However, a 2018 mathematical model from researchers in France resolved this by demonstrating that the acoustic signature of knuckle cracking matches the partial collapse of a cavitation bubble. The bubble doesn't fully disappear. It partially collapses, creating the sound, while a smaller stable microbubble remains behind. This explains why bubbles are still visible after the crack is heard. The partial collapse generates a pressure wave, a shock wave through the fluid, that we hear as that characteristic pop. The dominant frequency is around 129 Hz, with a sound pressure level of roughly 83 decibels. That's about as loud as a busy restaurant. Try to crack the same knuckle immediately after. You can't. There's a refractory period of approximately 20 minutes. Why? Because the gases need time to redissolve into the synovial fluid and restore the pressure equilibrium. Until then, no new bubble can form and no new sound can be produced. Now let's address the elephant in the room. Does cracking your knuckles cause arthritis? The overwhelming consensus from medical research is no. Multiple studies have found no evidence linking habitual knuckle cracking to osteoarthritis. The sound is simply gas bubbles and fluid. No bones are grinding, no cartilage is being damaged. That said, excessive or forceful cracking can theoretically cause minor soft tissue irritation or ligament laxity over time, and one study noted slightly reduced grip strength in long-term habitual crackers. But for the average person, it's harmless. So the next time you hear that pop, remember, you're not breaking anything. You're witnessing a miniature physics experiment inside your own body. A bubble forms in synovial fluid under negative pressure, partially collapses, and sends a shockwave through your joint, all in a fraction of a second. It's one of the smallest sounds your body makes, and now you know exactly where it comes from.